Hello. Yeah, welcome to session 2 in programming languages, where I'm going to talk about C sharp, right? So, in earlier session, we just created uh, one program, and you saw the whole structure of the program. Now, here we are going to experiment a little bit with classes. So, let's go ahead and create a new project, and this is going to be a C sharp console application, which is going to be .NET framework. We are later going to look at .NET Core, but for now we are just going to look at .NET framework. And here I am going to name this as chapter 2 in C sharp. Okay, so all the in this series, all the C sharp related chapters will go like that. So let's go chapter 2 in C sharp, and this is going to be a console application with the .NET framework, and I can choose what framework I want to target. Okay, so by default right now it's 4.6.1. I'm going to say OK. So it's going to create one empty class which has a entry point as main. So in C sharp, okay, there everything is going to be a class, or it's a object oriented. It's a perfectly object oriented language. Here everything has to be inside a class. There are not even global variables. So if I try to declare a variable over here, or let's say a variable over here, I'll not be able to create a variable because everything should be inside a class. And even the main entry point is inside this class, which is called program, and the program.cs is over here, which has that code, right? So here you see this one has, let's see what this is. Okay, so this class program, okay, has a static void main. So let's go by parsing out what is that. So static means that main is a method of class. So it's not a method of object of this class, but it is a method of this class called program, right? So here this is a static method. So if I was to use any variables, they also need to be static, right? So you understand what that is, right? Okay, so for example, let's create a static. So static classes are members of the static methods are the member of the class, not of the object. And similarly, static variables. So for example, let's say I have a static string, and then I have got string called name, right? And then I have a static int, let's say called age, right? So these are again members of the class program. These are again, if nothing is specified, they are public. Okay, so they will be accessible to any class outside, any object which is from a different class. So had I set this as a private, okay, then they become private. So they will not be accessible from anywhere outside the object or outside the class. So that's there. Now here I can basically do simple query from the user. I can say console. So console is also a class in the namespace system. Okay, console dot writeLine. Okay, so writeLine is a static function. That's why it can be used with a dot operator with a class, right? So writeLine, and I can say here anything to the user. I can say here enter employee details, right? And then I can say name is equal to console, okay, dot read line. Okay, and this is going to read a string from the user which it is going to assign to name. Now here I could have used a write also. So I could have said this, enter employee details, and then I could put a new line character here and say name, right, and say this, correct, and then console dot read line will put the new line feed after the name, right. Now, okay, now I can also say console dot write enter employees name age, so I can say here age, right, and then I can say age is equal to, now here everything dealing with console in .NET or any IO is going to be string, so you have to parse it. So basically any variable here or any data type here is going to be a class. So int is also a class. So int has got a method called parse. So I can parse whatever is being entered, right? So this can be console dot read line. So whatever is the input, okay, that will go into the age, and then I can display this, okay, I can display what I have read, but then I can do the following. I can create a class called employee, correct, and this class is same as the program class, right, but then it doesn't have any static members, but it can have other static fields. So for example, I can do a static id num, and it will start, let's say, with 0. So when I say static int and id num equal to 0, I can also call this as, let's say, private or protected. So let's say protected. I'll show you why I'm putting protected, but if I put a private here, so I can put a private also. That means that this number is not going to be accessible from outside. So what I'm going to do is, as soon as I said static, this id num became a variable with employee class, right, and this has become, this is static, so that means it's going to be assigned only, this statement of assignment will take place only once, then it can be updated any number of times. So basically I will add employee 1 2 3 4 like that, 0 1 2 3 4 like that. So this is going to keep the track of which employee I have added. Okay, so that's that. Then I can say private, okay, name, sorry, private string, and that's going to save employee or employee name, right, and then I can say private int, that's going to save employee age, okay, and then I can say private int, and then I can say this is employee ID, correct. So now this is there. Now, okay, I can do a public void create employee, okay, and public void create employee, and this is going to receive a string called name, and it is going to receive an integer called age, and then it is going to basically create a instance of this class. So this is all these fields here, okay, are private, which means that I cannot access them from outside, right? They are all private. So what I can do here is, so for example, okay, I'll show you an example in a bit. So here I can say, so when I'm creating it, I can call this function to assign the values. So what I can do is, I can say employee name is equal to name. Then I can say employee age is equal to age, right? And then what else I want to attach is employee ID. Okay, employee ID is equal to ID num plus plus. Okay, so this is a method which is public, which is accessible from outside, but then the other fields, which are employee name, age, and ID, they are not accessible from outside. So for example, if I was to create a object or instantiate an object of employee, I can say employee, and let's say emp1 equal to new employee, and I can create this new employee like this, and then I can say employee1 dot, and I can call this method create employee, and to this I can pass the string. Okay, so the string I will pass is the name which I have read, comma, the age which I have read. Correct? So this is how I have instantiated a object of this class, right? And I've used a public method which is a member of the instance. This is not static, right? So it is a member of the instance, right? And I have used that member method to assign values to this, right? So now I can print, but if I have to print this, I cannot do it from here. So if I was to say console dot write line, okay, and if I put here details of employee, right, and then a new line, so this is a write line, and then I say console dot write line, and here I am going to say employee name, and then here I want to put here the name of the employee, comma, the name of the employee is going to be emp1 dot. So you see here, other than this private method, this, okay, the private fields like the string employee name, string employee age, employee ID, they are not accessible. They are not accessible from outside. So this is data is protected. So if you look at this class, right? If you look at this class employee, okay, what do you see? You see that employee has a certain fields or variables, and it has got the methods, or what you call functions in C, that they are called methods here. So this unit of data and method, this unit which is called class, is encapsulating the data field and the methods. So this is referred to as encapsulation, right? Now you can also see that I cannot access, okay, anything which is private in here, right? It's not available here. So this is called data hiding. So one of the properties of this encapsulation is that I can do data hiding, right? Now only the members which the method members, which are the members of this instance of this class, can access this data fields, Okay, so this is called data hiding. It's not accessible outside. Now I can do one thing. I can create this to be a public, right? And here, if I do employee, now employee name is accessible here as soon as I made this public. But then this is not what you would like to do, because in your database anybody can come and change the name, right? Or the age or the ID. You don't want to do that, right? But at the same time, you want to access these, right? So I cannot access this here, so I can access it in another way. Okay, so that is called properties. So for example, I can write here string. So it is going to return a string, and then I'm going to say employee name. So this is the name of the property, right? And then I can say this is going to get, right? So this is going to get something. Okay, so it is going to return, let's say employee name, and this. So now I have got a property. Okay, so now this property is a read-only property from outside. You cannot set it, you can only get the value. So for example here, now I have a property, okay, it has to be public string employee name get. Okay, so employee name here, okay, it can get you the employee name, right? And similarly I can add the properties. Now if I try to set it, if I say emp1 dot employee name equal to Suresh, right? So it says that no, there is no set function here. Okay, so I cannot set this property. I can get the value, but I cannot set them, right? So for this, if you want to be able to set it also, you can put here a set function here. And sorry, so this is outside. I have to go outside and say set. And here I can say employee name equal to value. Okay, so now it has a set property. Now if I say this emp1 dot employee name equal to Suresh. Now here, okay, we have allowed it to do we have allowed the property to set a private. Okay, so let's make it private back again. Okay, we have allowed, sorry, not here like this. Let's say emp1 dot employee name is equal to Suresh. Okay, so now we have allowed a private field to be updated by a property. Okay, by incorporating a set method. Okay, but which is against what is the purpose. The purpose is hiding. We can only have a read only. We cannot have a write. So in that case, I would not have a set function if I want to do a read only property. But if I want to have a read write property, then I have to put a set here. So now you can see that this is now illegal. That's why it is in red. Okay, so now I can repeat the same stuff with other base data fields here, which are private. I can say employee age, and it returns a integer, not a string. It returns an integer, and it is going to return age, right? So now I'll have access to the employee age, but again I can only read it. It is not that I can update it. It is done only once. Here I can put age, and I can put here dot employee age. And similarly, if I want to put a ID, so I can put here another property I can declare here. So you understand the difference between a property and a data field, right? So a property is like a link between the data field and the outside world. It can be read, it can be written if there is a get and if there is a set. It can only be read if there is only a get. It can only be set if there is only a set. If it can be read as well as set, read as well as written if they are both get and set, right? So this is a property. A property basically is just like a pipe between the internal data fields and the outside world, right? So here I can say employee ID. Okay, sorry about that. Control C, Control V. And here I can say employee ID. Okay, and that is going to be another property dot employee ID. Again, this is a read only for outside world. You cannot write it. So what did I do? I created a class called employee. I declared a number which will track the employees if I keep adding, right? So if I keep instantiating, this number will go 0, 1, 2, 3, 4. So it will be, because it is static, it will be created when the class is created. So it is a member of the class. Okay, and when you instantiate, this will not happen. Okay, so then when you instantiate, so there are certain private fields here, right? It's like the name, which is a string, age, which is integer, and ID, which is integer. So now here I can call a function to create this so once you have instantiated, to assign the name, age, and the employee ID by calling this function. So I call this function to do that. So when I say employee emp1 new employee, it just created a pointer to an instance. So it created a pointer to the instance of that class, which is stored in emp1. Then emp1 dot, okay, then this is the method which is a public method because it is declared public, and this public method is going to assign name and age to the private fields here. Now I am going to print the private fields by using properties. These properties basically are like the pipe between the data fields and the outside world, right? Here I can also do validation. So if somebody is trying to enter some string for a age or some string for an employee, then it's not going to accept it. So I can do a validation here. Okay, so let's see if this code works. Okay, so I'm going to build solution. Okay, it is built. Then I'm going to say start without debugging. Okay, enter employee details. So let's say my name is Anurag and my age is, let's say, 28. So details of the employee. Okay, here there is a problem here. So let's see what's the problem. ID num. Oh, in the printing, employee ID. Why am I doing age here? Sorry. Okay, so I was returning wrong stuff. So let's build this again. And then I would debug. It's a name as Anurag, age is 28. So this is details of the employee. Employee name is Anurag, I entered. Employee age is 28. Employee ID is 0. Right. Now let's create another employee. Okay. But this time we want to do it slightly differently. Okay. So to do that, I use another method here, which is going to be a public. And this method is not going to return anything, so I don't put anything, not even void. Okay, then I give you the name of the class itself, and here I am going to receive something, which is a string, and call it name, and then int call age, and then here I am going to, so basically, okay, so here I can say emp name is equal to name, and then I can say emp age equal to age, then I can say emp id is equal to plus plus, sorry, id num plus plus. Okay, so now here what I have created is called a constructor. So the constructor, so as soon as I create a constructor here, it says that the old constructor is not valid because the old constructor doesn't have a string here. So if you're trying to construct an instance of employee, those parameters are not there. So once you introduce your own constructor, the default constructor is gone. Otherwise, there is a default constructor. So what you have to do is you have to create your own constructor, which is a blank constructor, and this constructor is going to do nothing. Okay, maximum this constructor can do, because I'm calling the create employee, sorry, this is not required, so I'm calling the create employee here, right? Now if I don't create employee like here, then how would I do it, right? Okay, so this constructor would never be called. In a sense it will be called, but then you have to call this function to complete the completely construct the instance of that. So now having done that, so I have taken away the default constructor when I created a new constructor. So I have to provide the default constructor, which is empty. So this one is still valid. Now let's do another this thing. I can say emp2, sorry, I can say employee. Okay, emp2 equal to new employee. Okay, so now I have got choices. It says 1, it says an empty constructor. 2, you can provide a name here. So I can call Suresh, and I can say his name is, his age is 30. So I have created, oh wait, okay, sorry about that. Okay, so I have created a new employee, and I can just repeat these. Control C, Control V, and here details of new employee. So here I can say emp2 and the same dot. Okay, so if I put dot, the employee name is available because it's a read-only property. Okay, so this will return you back Suresh, and this will return you 30, and this will return you the employee ID num, which will be basically a plus plus. Right, so let's run this build solution. It's slow. It's done, and then say start without debugging. It's quite slow. Okay, so slow. What is happening? Control C. Oh, it's not even closing. What got stuck where? So this is still there. Okay, let's do this again. Run without debugging. What's going on? Okay, let me put you to pause and see what is going on. Okay, sorry about that. There was some crazy update going on. But anyway, so what did I do? I created or instantiated a EMP2, another employee, and I have used a different constructor to construct it. So I have built it. So let's go ahead and debug this. So it says employee, enter employee details, Anurag, and age is, let's say, 28. So the details of employee: name, age, ID. Details of new employee: name, age, and this ID is now 1 plus. So it will be 0 plus 1. Okay, so this is how I have uh, instantiated an object, okay, of a class. And this I have explained you what is encapsulation, and I have explained you what is data hiding. Now let's say another thing which is called inheritance. So instead of this as a private, I create it as protected. So basically it will be this field will be shared with the child or child of this class, but it will not be accessible to anybody outside. So similarly, let's create another protected property and say this is a boolean, and it's a is manager. Okay, and this by default I'm saying is a false. Okay, so now what's going to happen? I'm going to display what happens with this manager. Okay, so let's see. Doesn't matter. So let's write there console dot write line. Okay, and I can say is placeholder 0 manager, and then I say placeholder 1 true or false, and then I can say emp1 dot imply name comma emp1 dot is a manager. Okay, so did I create? No, I didn't create the property. So let's create another property which says it is a public, public, and returns boolean and is a manager property, which is again a read-only property. So I only have a get, and I will return the value of is manager, right? Sorry. Okay, so is a manager. Okay, so that I am going to read here dot is a manager. So that's the property. It's a read-only property. So that's what it's going to do. And same thing I'm going to do with Suresh. So here I created Suresh, and here I can say emp2 is a manager. Okay, so if I run this, build this, and run this again, and if I run security scan, your administrator requires a security scan. Why is it always doing that? Receive a message says that okay, don't worry about this. So say Anurag, say age is 28, and says details of employee name, age, ID. Is Anurag a manager? Answer is false. Again, is Suresh a manager? Answer is false. So some spelling mistake is there. So why there is a pop-up on security whenever I run this code? Let's do this again. Build solution and say start without debugging. So why does this scan could take up 10 seconds? Okay, it took 10 seconds. I don't know why this security pops up. Okay, let's put here Anurag, age 28. Says, is Anurag a manager? False. Is Suresh a manager? False. Okay, so now I am going to create another class. Okay, so in the same namespace, I'm going to say class manager, which extends the class employee. So this would be called inheritance, right? Okay, so in this case, I have nothing in here. Only thing is that if I want, I can declare a constructor. So I can say public manager, and this is going to receive a string name and int age. And here I can basically do nothing, but here I have to pass this on to one of the constructors here. So as to construct employee, right? So I can just simply say employee. So this is called chaining. So it's not called employee here. I will call it base. It will be called employee in case of Java. And there we will say extends manager extends employee. So here you would say manager extends employee, but in C# you will just say manager employee, and here you will pass on what you received in this constructor to that constructor, and that constructor basically is referring to this constructor. Okay, and here I can just set this one is a manager to true. So I can say base, because it is a protected, so it will be available here. So this is a get only property, but then this is a field, right? So this field is a manager equal to true. Okay, so what did I learn? I extended the employee class by a manager class, right? So which is the extension of the employee class. And here I can write anything related to the employee, and all the protected fields would be available here. So here I would have to do one more thing, which is going to be base dot employee ID. Okay, so employee ID is also private, so it will not happen on its own. Sorry. So I have to declare this as protected, right? Or I can, so I don't even need that, because whenever the constructor is called, it will automatically do that, right? So I don't need that. Sorry, the constructor of employee would automatically assign that, because I have called that constructor here, right? Okay, so once I build this, okay, and I debug this, okay, let it take 10 seconds. I'll later figure out what that is. So this is Anurag, age is 28. So details of employee. So Suresh is a manager, but I haven't done anything with this class. So I have to instantiate a manager now. So manager is Rajesh. How's that? Okay, manager Rajesh equal to new manager, and here I have only one constructor available. So, or I can call this emp2. Don't want you to confuse you. Manager, and here I can give a name, and his name is Rajesh, let's say, and his age is 45. Really old guy. Okay. Okay, emp3, sorry. Okay, so I have created Rajesh, and here I can print the same stuff, but this time I'm going to say details of manager. So I'm just going to copy this, Control C, Control V, and details of manager, and I'll call this as emp3.name, emp3.age, emp3.id, and emp3 and emp3 is a manager, right? So now you see that I created a object, instantiated object of the class by giving the name and the age, and it chained that to the base class, which is employee, and then that base class incremented the number id num and assigned it to employee id, and here I set the base class is manager to true instead of false. So I expect that when I print this, I will be getting here a true, right? So let's build this again and go to debug. So again it will pop up here. Let it take 10 seconds. Okay, I'll put here my name. My age is 28. So details of employee is so, is Anurag a manager false, details of new employee Suresh, employee ID is 1, is Suresh a manager false, details of manager, employee name Rajesh, age 45, employee ID 2, is Rajesh a manager, answer is true. So what did I do? I showed you how to inherit. So manager inherits all the fields and even the members of employee class, right? So that is called inheritance. So we have seen encapsulation, we have seen data hiding, we have seen inheritance. Now there is another thing which is called polymorphism. So what is polymorphism? So for example, there is a method here, and to this method I am passing string and age. Okay, I can have another method, public void, and create employee, and this version is sorry about that, typing mistakes, and this version is just an empty version. Okay, so both are returning void, both are having same name, but they are having different signatures. So what I mean by signature? I mean by signature is, so I can call here writeLine, console.writeLine. Okay, empty function call, ampty function call, right? So this is the empty function call, right? So now here the name of the method is the same, the return type is the same, so that doesn't count as a signature. What counts as a signature is what's inside the parenthesis. Now there can be different things inside the parenthesis, right? And here you have string name and integer age. Here I'm passing nothing. I'm passing void. So it's just printing that. So if I was to call this function over here, create employee name and age, then that's going to do that. Now here, if I want, I can call this over here also. So I can say emp3 dot create employee. Okay, and this is a function. It's a method which is not the same method as over here, which is called over here. It's doing nothing over here, but then it has the same name, right? But it has a different signature, right? Now, if I just build this solution and I start without debugging, so 10-second thing will come here. Don't worry, let's wait for 10 seconds. Okay, so Anurag, age is 28. Okay, empty function call. Okay, so here I have a same name, same return type, okay, same qualifier, both are public, right? But then one is receiving name as a string and age as an integer, and the other one is not receiving anything, right? So you can repeat the name of the methods as long as they have different signatures, right? Their return types doesn't account for signature. They have to be same, right? Otherwise, then that will be a different function. So for example, if I was to say int, okay, then I cannot call this create employee because then it is confused that the return type has changed, right? So it has to be void. Now they are polymorphism, or this is now known as polymorphism, right? So an object-oriented programming is based on 4 pillars. One is encapsulation, which I have shown you. Other is the data hiding or abstraction, right? Which is with the help of private, protected, and public. Then there is inheritance. You can inherit from a class. So when you inherit from a class, the relationship can be compositional. So basically, the extended class or a child class may be a part of the base class, or it may be extending the base class. Okay, so it can be another type of a base class, right? So basically, that is called inheritance. And then the 4th pillar is polymorphism. So polymorphism, you have seen in another way, is that in constructors. So what a constructor does, it's a special function which doesn't return anything, but the constructor constructs the instance of that class, or it constructs an object. Okay, so if you see here, there are 2 employees here. One of them receives name and age, other one doesn't receive anything, right? So this is also an example of polymorphism. So these are the basics of object-oriented programming. So I'm going to extend, I'm going to put this aside. So I'm assuming you will be very clear with this, and I'm going to proceed with developing the subject material, which is C#, right? Okay, so I'm going to stop here.